Alright, welcome back. This is Raj. This is SaaSx16. So it's been some time since the last one. Uh, yeah, starting to peel off the the chits that I had. So this one I am probably going to go into. You'll not see this, so no way showing it. No point showing this to you. It's some sort of a domain algebra. I have been getting into polymathy since 90. I've been explicitly, honestly, everyone is sort of a journalist when they start out. They explore and they do a whole bunch of things. So there's that. But yeah, as you get older, you start to specialize. So polymathy is really not something that you discover, but something that you just become aware of. I mean, someone can be good at multiple things without knowing such a concept exists, or without knowing that distinctions between those things exist. So, by things, I mean to say domains. By domains, yeah, it could be anything. It could be any sort of domain. Could be martial arts, could be powerlifting, could be computer science, could be artificial intelligence, could be anything. So, uh, a domain is yeah something that we sort of have a vague uh idea of separation from each other. Like that's mostly what I call it. It's like a pretty fuzzy definition. So domain algebra, when I say that, uh, it's sort of a very pseudo mathematical thing. What you can do is you can operate on the domains, combine them, separate them, have operators on them. So basically, you could take multiple domains, combine them into one, try to make something of that. So for example, uh, one interesting exercise you can get into is whenever you think of a subject, try to dissect that down into its constituents. Constituents in the sense that the fundamental axiomatic domains that you might already be knowing, uh, that will help you grasp the domain that is under consideration for the moment. So for example, artificial intelligence, there goes a whole bunch of mathematics into it, a whole bunch of computer science into it, uh, a whole bunch of architectural decisions into it. So like sort of an art in terms of intuition as to how you have your architectures. Uh, there's a yeah, I mean, so there's hardware. So there comes to like electronics and physics. If you go to the inference side of things, and yeah, that's what you can think of when you think of EA, and you could really think of really specific things as well. So, breaking down a domain into its constituents, that could be uh, assigned to be one sort of an operator. Now, try combining two domains. For example, if you get into like mechanical engineering and like let's say like biology, you could get into like biomechanics. Uh, well, how about creating a cyborg, or like think about swarm intelligence when you like do some sort of biomimicry and like have drones that can mimic the flying patterns of a beehive, of a, I don't know what you call the group of bees, but whatever that is, swarm intelligence, or like yeah, whatever biomimicry does. So that sort of combination of domains is also sort of an operator in the algebra. Uh, you could also think of projections, by the way, projections in the sense that this is like more akin to analogies. So you try to see one scenario through another. So, for instance, this cup, the age-old example of like the cup being similar to a donut in terms of topologies. Uh, Now you're just projecting the intelligence that you've gained from like topologies, and yeah, projecting that to like real world and like shapes and stuff, and like this is like structurally similar to a donut when you think in terms of topologies. But other than that, there's a whole bunch of differences. So the projection of a donut and a cup and on the domain of topology coincides perfectly. So there's that. Yeah. So projection is one. Uh, yeah. Then the selection is probably selection. Yeah, you choose to like separate out certain functional aspects or certain behavioral aspects of a particular domain. That helps you explain something else. It's just more of a pick and choose sort of thing. It's like sort of yeah, it's sort of a buffet. I mean, Yeah, you like whatever you choose whatever you like. So that sort of thinking uh helps you get into this mindset of everything's related a little more. I mean, you can honestly express a lot of things in terms of a lot of perspectives. So explicitly being aware of this, that a lot of domains can be operated upon. Uh, okay, the perceptions of those domains can be operated upon is a pretty neat thing to be aware of, is what I'd say. Uh, Now, as you like study a whole bunch of things. Now, what I do is I do a lot of comp sci, a lot of most of it is career oriented. A whole lot of it is curiosity driven as well. Uh, when you get into comp sci itself, when you like break it down into subdomains, there's a whole bunch. There's yeah. I'm not going to get into those right now. But slowly you start to see relations everywhere. Or let's say if you get into different styles of martial arts, there's the different strategies to what people do, like how they think of like closing the distance, or what's going to take the minimal time, how to be efficient, the 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 science of like leverages and stuff. Uh, everything has a certain view about something, but then they are projected by a common goal of like, I don't know, using your body to like achieve something common, like, I don't know, hurting the other person or being efficient in your movement, or like some sort of goal. Uh, so yeah, think of any sport as well. Like think of like the generic class of racket sports, or the generic domain of racket sports. Uh, Honestly, I've been playing what badminton, table tennis, pickleball. I haven't done lawn tennis, but yeah. One racket sport, once you like usually get good at it, it sort of has a weird carryover to the other ones. I don't know if you've ever heard this, but then yeah, so that does happen. So it's not even that you have to force this cognitive common projection onto these domains. You also realize this in your day-to-day experiences. If you learn to drive a certain sort of a car, you'll also be better at driving the other sort of car because there's a lot of transfer learning happening. Uh, yeah. So everything is like ultimately like super specific in its own terms. For example, every television remote is like it's going to be its own exact television remote. Uh, but then there's like some common uniform ground uh, for every domain out there as well. So to be able to like traverse up and down this hierarchy of domains, rather than hierarchy, I'll say that like okay, if you like think pin it to like one domain and make it the root, then it becomes a hierarchy. Uh, but then if you look at it from the bigger picture, it becomes a graph. To be able to like traverse on this graph of domains, which maps the combinations of how they work together and all that they can do. That is yeah, that is like a pretty neat thing to be aware of. You might already be doing this implicitly, is what I'll say. I mean, usually these sort of things, yeah, you don't. It's okay. What's the point of being aware of it? It opens up a whole bunch of interesting mental games. Uh, Whenever I'm bored, now I can spend a whole bunch of time without pulling out my phone. I can just look at leaves around me on trees, and I notice sunlight and I notice wind, and you can start thinking about like systems engineering as to like if you treat the leaf as a system, what are the inputs, what are the outputs, what's happening in there, what is it transforming? Uh, yeah, or I mean, it's like having a certain sort of it's a different sort of X-ray vision, you would say. X-ray vision in the sense that okay, it's not the exacts, but then you're again building models of like what you perceive around you. So that is a pretty interesting game. Uh, a really interesting one is like the softer domains where a lot of stuff is probabilistic. Human psychology, I mean, I don't know if like if you're like deterministic or like probabilistic or like I don't know. if you're like, I don't know, whimsical or whatever. But then there's a whole like there's a lot of certainty to like how we behave and like what patterns we exhibit. So that's what like a whole bunch of the hard neuroscience gets into like human psychology uh, to 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 move between that very robust aspect of neuroscience of like how what exact neurotransmitter is moving where and the softer side of like psychology of like humans or like how they behave and like what are they feeling in a moment and like what will happen if you like say crack a certain joke or like what so you say certain things and like how they react and stuff like yeah so that interplay between the hard and the soft is also sort of a nice uh, domain operator, I would say, is like tuning a whole bunch of dimensions. So rather than thinking in terms of a graph of like discrete nodes for domains, uh, you could think of it as a continuous domain space, uh, a high dimensional domain space where the orthogonal dimensions is if you can vary a certain axis or a dimension, you sort of end up tweaking that domain a little bit. And like one of my hypotheses, uh, being an aspiring polymath, is every point in the domain space is connected, as is there's no vacuum in there. But then how do you express this? Because like this is more of a movie sort of space. It's not like the ones that we're used to. So, uh, honestly, this if you like think in terms of mathematics for this of like a I don't know a semantic field, probably not a scalar or a vector field, semantic field. Uh, yeah, it opens up a whole bunch of different creativity. So yeah, mathematics is something I like to apply uh, like these sort of things. I mean, I have done it before in like semi-tensoric spaces a while ago, where I was thinking of like, let's say, the movie Matrix. I have a poster nearby, by the way. It visualizes the world in like binary, binary in the sense like, of course, it even shows Chinese characters and stuff. And if you like really zoom in onto like when they're like looking at the scenes on the screen, but then it's encoding. So it's all ones and zeros. So it does not allow for symbols though. So yeah, like a symbolic aspect to it is missing. So I was like, we should also have a movie called The Symbol from comp sci perspective. So like symbolic algebra and stuff. So yeah, mathematics is like a really neat thing to have a okay, so that gets me to the notion of root domains or like more fundamental domains, domains that will help you understand a whole bunch of other stuff. So mathematics pops out to be one, linguistics is another, uh, physics or science or like the notion of science of like the scientific method, that is also like one really fundamental one. Statistics is like a pretty great one. So if you really want to be a polymath pretty quickly, it's good to invest your time into these sort of fundamental domains or like root domains, because once you grasp them, it's like pretty nice and easy to like apply them to like other stuff. Uh, yeah, biology and botany and like how like molecular structure works and everything and like chemistry and that sort of stuff is also like great to have. Human psychology, like how just general humans behave and like observation in general or like just the skill of yeah asking great questions. I think this should be a domain. It's not a domain. Maybe this should be a domain of like the theory of questions or like in terms of like the theory of seeking knowledge is what I'll say. What is a good question? What makes a good question is something that I explicitly would like to like have to create a domain. It's like, yeah, I mean, if I knew early on what really is a good question, what really is a bad question, to like formally theorize this will like help accelerate a lot of people's cognitions I don't know if I'm like feeling that right or whatever. But yeah, honestly, I would have benefited a lot if I knew like what is a good question, what's a bad question, like what is worth thinking about. Uh, yeah, what is worth cognitively spending upon, or having weights to thoughts, cognitive weights to thoughts. So, so this thing of like, let's say asking good questions. What is a good question? Let's say you are a model that can only ask questions. You're dropped in like a vague domain space. The objective you have is to ask questions, gain answers, assuming oracles, and yeah, to just increase your knowledge, your grasp of the domain space. So asking those questions are like, okay, also maybe like strategizing how you gain the most knowledge based on your actions, like devising experiments for like most information uh, exposure, or like uh, yeah, gaining the most information, or like how do you frame it, or like decreasing information entropy, or like whatever. I don't know how you see it. So like in domain spaces, how would I frame this? So that's another interesting question. So also like okay, one more interesting operation would be like going from the abstract to the really pragmatic in terms of a domain. So like you go higher order, you abstract out the generics. Uh, yeah, you when you get pragmatic, it's like you really think in terms of black boxes, and yeah, you just see what stuff does. Now a pen can write, but a pen can also murder someone because it's like sharp and it's got a point, and like it's easier to like exert a lot of pressure and like penetrate the skin with a little amount of force compared to let's say your own fist. Yeah, I mean it's easier to murder someone with a pen than to murder them with a fist. So that sort of stuff. Yeah, I mean, but then if you think it as abstractions, both are just matter. Uh, so yeah, so like pragmatizing and like abstracting out stuff. That's also an interesting operator. So yeah, I mean, why do I think these is like uh, spending a whole bunch of your time on your phone is not fun. So there's that. That's those mostly that. That's on domain algebra, I guess. So I guess that's it for the day. What is the point of this? Uh, if you are into polymathy, if you are looking towards, if you're looking forward to like grasping a whole bunch of domains, uh, it's good to be aware of like how well connected a certain domain space is, or like a domain cluster is. Depends on how you think of it. I think it's good to think of it. Okay, the model that you think of something in is also a domain in itself. So you could think of something as a graph of discrete nodes, or a sort of a GUI continuous space. So like switching between that model in itself is also sort of an operator for like uh, yeah, how you perceive stuff. So like the theory of perception, I guess. And definitely like the theory of asking good questions should be sort of a domain I need to like get into, I guess. uh yeah, that's mostly that, I guess. uh so yeah, what do you do with this information? uh what I say is, I don't know, yeah, do whatever I mean, yeah, whatever with it is. That's that. Everything doesn't need to have purpose, I guess. This does have a purpose. It's just like a sort of pretty vague purpose. There's a whole bunch of domains that you do not know the purpose of when you're like learning them. There's more of an exploratory thing that that yeah, this is more of an exploratory thing, I guess. So again, uh, having a purpose in mind when exploring a domain versus just like pure exploratory stuff. Yeah. That is also sort of a domain. That is also sort of a domain operator. So all these things like alter your actions a whole bunch when you're like studying and stuff. It's like a really good generic uh, dimension of studying that you should be aware of. That if you tweak certain parameters, there's like you could alter how you have fun and stuff. So that's that. I mean, If I'm like finding something boring, I tweak a bunch of parameters and like I make it interesting. So in a lot of places, of course, you cannot do this at work because like yeah, there are defined goals and whatever. Uh, but yeah, if I'm like studying something by myself, if I'm finding the usual route boring, I will do a whole bunch of things to make it interesting. No, impose certain constraints by myself, or like introduce some more freedom in some other sense, or like have vague ideas, vague project ideas to execute and stuff. So to be aware of all these opportunities that you have to make something interesting is nice, is what I'm saying. I think that sums it up. So domain algebra, that's what it is. We have another crumpled note that you can dump into our collation of processed ideas. So there's that. Thanks for tuning in. This was Raj, and this was SaaSx16. See you next time on Conver Industries.